Welcome to session 2. This is our lesson for Tuesday, August the 10th. Today we're going to continue with the discuss it portion of the try it, discuss it, connect it. So yesterday's lesson was all about you trying a problem and then discussing it with someone. Today we're going to go over a method called tiling. We're using the same problem from yesterday. So we're still talking about our problem with the rectangular postage stamp that has a length of 3/2 inches and a width of 3/4 inch. And we are still talking about how to find the area of this stamp. So what we're going to look at is this tiling method. So this is the picture it. So what the tiling method says is that you can make little tiles using unit fractions as your side lengths. The thing that we need to know about unit fractions is what they are. If you have 2/6 and you want to make this divided up into its unit fractions, you would have 1/6, that is 1 unit, plus 1/6. That would give you 2/6. Notice here that the denominator is still 6. If you had 5/6, you would still have 1/6 as your unit. But this time, if you wanted to show 5/6 as unit fractions, then you would add it together 5 times instead of 2 times. Whoops. I'm out of room on that side of the screen, so I'll just come back here and add it over here. So 1/6 added 5 times. So with this particular problem where we're talking about 3/2 and 3/4, again, we want to look at our denominators. Our denominator for 3/2 is 2. So our units would be halves. So if we had one of those, that would be 1/2. Then looking at 3/4 of an inch, looking at our denominator of 4, would mean that our unit, 1 unit, would be 1/4. Now we can take that information and find the area of one tile to then find the area of the entire stamp. So they have another box here, another model that they have drawn. This is the postage stamp. And here is how they got that box. What they did was they created a rectangle. And again, this is how they got that box. They created a rectangle and they said 3/2 inches. If I broke that up into its unit fractions, that would be 1/2 plus 1/2 plus 1/2. So I would need 3 1/2 pieces. So each column is 1/2. Then they looked at 3/4. And they said if I broke that up into its unit fractions, I would have 1/4 plus 1/4 plus 1/4. So then they divided their box again, but now we've got fourths. So we have 1/4 3 times. If I know that area is length times width or side times side, I can now say 1/2 times 1/4. That will give me the area of one little box. 1/2 times 1/4 would be 1/8. I don't have one 1/8 box. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 1/8 boxes. So I now have 9/8, which would be my answer to the area of that postage stamp. So that is the tiling method. The tiling method, again, it says that you can take your fractions, break them up into their units, and then find the area. The next section of the notes page says model it. This model it is the area model. They do this model a little differently than what the students were taught last year with the area model. So the area model that the students used last year here at Southside is where they had the two colors that we talked about yesterday in session 1. So they would do 3/2 in one color and then 3/4 in another. This area model still has you create a model. This line right here, I don't know if you noticed or not, but it's a little darker than the others. So that's marking off where your hole is at. And then you have each hole divided into halves. And then they made a brace to mark off where 3/2 would be. So 3/2 would be 3 of those 1/2 boxes. Again, this is where last year the students would have shaded in the entire column. Then they said 3/4. Well, that would mean that I need 4 pieces. And I want to mark off where 3 of those are. So that would be 3/4. Now I only have to shade in the areas that I have marked off. So I want to go to the end of each brace. And then from there, it's the same as it was last year for the students. There are 9 boxes that are shaded. And remember, our hole ends right here. So there are 8 boxes inside of one whole piece. So 9/8 square inches. So again, this model it is still using that same area model. It's just done slightly different. And you may find that you like that version better than the area model version that you used last year where you're overlapping the two colors. So now that we have discussed 2 different strategies, we're going to do some connecting here. On number 1 on the connected page, it asks you to look back at the picture it and explain how to find the area of one tile. So when we looked at this, we looked at one tile and we found the area of this one tile, and then we knew that we had to add that this many times to get our answer. So how did we find the area of one tile? To find the area of one tile, we did 1/2 times 1/4. So we used that area formula. Now, question number 2 wants you to specifically think about, why did we use 1/2 and 1/4 to get our answer for 3/2 times 3/4? And the key here is to take a look at your denominators. At the beginning of this lesson, I had you guys pay close attention to the fact that when we take a fraction and we break it up into its units, we have to use the same unit. If I have 3/2 times 3/4, when I break it up into its units, I need to still be working with half and fourths. So that is why we're using 1/2 and 1/4, because those are the units of our fractions in our original problem. Which brings us to number 3, where it asks you to write an equation that uses the area of one tile to find the area of the stamp. Well, when we found the area of one tile, we said that we had to count up the amount of boxes that are in the rectangle, and there were 9 boxes. Now, you could write 1/8 plus 1/8 plus 1/8 9 different times, but there's another way that you could find that without having to write plus 1/8 9 times. Instead, another option would be 1/8 times 9, which would then give you that answer that we're looking for of 9/8 square inches. If you would like to change this, if this fraction that is greater than 1, or some students call it an improper fraction, if that bothers you, you are welcome to change that into 1 1/8. If you like it as 9/8, you can leave it as 9/8. Then we get to number 4. This question asks you to look at the area formula. So the area formula says length times width, or side times side. In this case, 3/2 times 3/4. And they want you to focus on the fact that you're going to take the top 2 numbers and multiply them together. And then you're going to take the bottom 2 numbers and multiply those together. When you do that, you should get 9/8 again. So the area is 9/8 square inches. Then number 5 says, does using the area formula, so the area formula is what you did in question number 4. This is the area formula. Does using that area formula give you the same answer as using tiling? So I want you to think about that for a second and answer that. Hopefully we said yes, it does give us the same answer. What I want you to do is I want you to think about that why. And I want you to write a response there. I want you to write why you think it gives us the same answer, no matter which strategy we use. So after you have done that, so you're going to pause the video and do that. If you have questions about that, or you're confused about how to answer that, then please have your parent message me and I can get with you about answering that question. But that is one question that I'm going to let you answer on your own. That brings us to question number 6. Question number 6 is another one that I'm going to let you answer on your own. And if you would like to discuss it with me, then I will be happy to do that on a Zoom with you. So number 6 says reflect. So you're going to think about all the different strategies: tiling, area model, area equation, and you're going to describe how one of them helped you better understand how to find the area of a rectangle with fractional side lengths. So to put that in a different way, which one makes more sense to you and why? What about that strategy just clicks for you? So that's what you're going to do on number 6. You're going to reflect back on the different strategies that we've talked about through session 1 and session 2. And you're going to decide, okay, is there one that really makes the most sense for me? Maybe it's the equation where you multiply the top, multiply the bottom. Maybe it's this new tiling method. Well, new for some of us. Some of us already knew the tiling method. Maybe that one makes the most sense. Or maybe that area model, where you model one fraction on top of the other fraction and see where they overlap. So you decide how to answer on number 6 and take some time to answer that. Once you are done answering number 6, you're going to move on to the apply it. There are 2 problems that I want you to focus on the apply it page, number 7 and number 8. And you are going to do those 2 apply it problems on your own. If you have questions or need help, again, please ask your parents to send me a message and I can Zoom with you to answer those questions. So you're going to do number 7 and number 8. Then you can skip over page 5. We're not going to answer those questions. If you've already done those pages, that's fine. If you have questions about those pages, you can ask those as well. But the other problem that I want you guys to focus on from the practice pages is number 4. I want you to make sure that you understand how to do number 4. So with any of these 3 problems, number 7 or number 8 on the apply it, or number 4 on the practice. If the problem tells you to use a certain strategy, then you need to use that strategy. If the problem does not specify how to solve it, then you can use any of the strategies that you would like to. Again, if you have questions, please let me know. I'm here to help you in any way that I can. If you want to do the other problems on these pages, you are welcome to do that. That is the end of session 2, and I will be back again for session 3.